Hi, good morning. My name is Stuart Bellwood. I'm a project manager in the innovation team at the MRA. Part of my job role there is to facilitate third-party access to our mine water. The purpose of that is for heat recovery. And this morning I'm going to give a presentation on delivering mine water heat from treatment schemes. All gone wrong. Yep, see. So across the former coalfields of Great Britain, mine water is routinely pumped to the surface. This is done for environmental protection, water level control and treatment before discharge. Because it's already been pumped to the surface, we have a real opportunity to recover heat. The water usually comes out between 12 to 20 degrees, so it can provide a dependable, continuous source of thermal energy. The MRA currently operates around 80 mining water treatment schemes. Many of these sites are close to towns, housing developments and industrial estates, all places that need heat. If we can build heat recovery into our treatment infrastructure, this can shift mine water from an environmental challenge into an asset that supports national decarbonisation. Using 2 case studies, this presentation will show how heat from treatment schemes can be effectively used in heat networks. Also, at the end of the presentation, I'll give a high-level view of the wider potential from mine water treatment schemes across Great Britain. Okay, and so the first case study is the Lindsay scheme in Ammanford, South Wales. It's a great example of small-scale heat recovery built into an existing mine water treatment scheme. It delivers a heat output of 40 kilowatts and was designed and delivered in partnership with a local specialist company, Thermal Earth. A challenge of some treatment schemes is the fouling caused by aeration of the mine water. At Lindsay, this was tackled with a closed-loop system using submerged heat exchangers installed directly into a settlement lagoon. The mine water doesn't pass through the heat exchanger itself, so the risk of fouling and corrosion is much lower. 2 energy blade heat exchangers sit submerged in the lagoon, but above the level of any ochre. The blades recover heat while still allowing the flow to move around them. The recovered heat is then transferred through pipework to a nearby building where a heat pump lifts the temperature for space heating. This design allows for the energy blades to be moved between lagoons during lagoon maintenance periods, so treatment can always keep running. It was commissioned in February last year, and it shows that even the modest treatment flows can still support useful heat recovery, demonstrating a replicable model for other small remote treatment schemes where full heat networks are not viable. Next, I'll show you a small video clip, and it just brings to light the scheme itself.
We're in sunny Wales today. It's a beautiful day here. We're near Ammanford in Carmarthenshire at one of the Mining Remediation Authority's mine water treatment sites. My name is John Ammonier and I work in innovation. Mining Remediation Authority treats water from old coal mines across the UK. So we've got about 80 sites that treat this. And my job actually is to look at innovative ways we can improve sustainability from what we do. So we use byproducts from the site. And this site in Wales is called Lindsay. Now today, actually the main reason I'm here is because a local SME, Thermal Earth, are putting heat exchangers into one of our lagoons. So the water we treat is actually above ambient temperature, it's 14 degrees C, and they're going to recover that heat to use in a warehouse to provide heating for the warehouse, which is a sustainable way of heating, and that's fabulous. So this is a bit of a poster boy, this Lindsay site, for all the sustainable options we're looking at within the Mining Remediation Authority.
My name is Nick Salini, I'm a Director of Thermal Earth, and it's a pleasure to be here today to finally see the implementation and installation of our mine water heat recovery system at this site in Lindsay here in Ammanford. We recognise the opportunity that surface mine water can offer to heat homes and buildings around the country by utilising heat pump systems. We hope this scheme is demonstrated to be scalable to other opportunities and sites around the country.
South sunny Wales. Okay then, so this slide just demonstrates some of the key technical data for the scheme. So the scheme uses 2 15 kilowatt multi-Q energy blade heat exchangers with a combined absorption area of around 60 square metres. They sit in a lagoon which mine water flows through at around 10 litres per second. At Lindsay, the mine water is 14 degrees, and across the heat exchangers, we see a drop of around 3.8 degrees. That energy then feeds a 35 kilowatt heat pump into the thermal earth building. In the first year, the seasonal coefficient of performance was 4.6, so for every unit of electricity we use, the system delivers more than 4 units of heat, demonstrating how effective mine water can be as a heat source. So overall, the Lindsay scheme shows that you can get reliable, efficient performance from relatively simple infrastructure, as long as the design fits the constraints and characteristics of the mine water treatment scheme. Okay, so the next case study we look at, this is the Seam Garden Village project. This is the first large-scale mine water heat network delivered from a treatment scheme in Great Britain. It's located in County Durham and uses mine water pumped from our Dordon treatment scheme, and it will provide low carbon heat to a new residential development of 750 affordable homes. Durham County Council leading the project with ourselves, Carbon Homes and Vital Energy. Vital are designing, building, operating and maintaining the heat network under a 40-year concession. The heat network has been designed to integrate and work alongside the treatment scheme infrastructure without compromising any regulatory compliances. At the time of this presentation, construction is complete and the project is in the final stages of commissioning. Once it's operational, Seam Garden Village will be a nationally significant example of how mine water heat can support large-scale housing growth and help reduce fuel poverty. Okay, on this slide you can see some of the more technical details of the scheme. So the mine water is pumped from the Dordon shaft at 20 degrees, and that's all year round. The treatment scheme runs at a flow. It has an average of about 90 litres per second, and from that we've guaranteed an average flow of 75 litres per second into the energy centre. Inside the energy centre, so it's going to take around 5 degrees of heat, and that is recovered using a plate heat exchanger before the mine water continues off into the treatment process. The site has a 733 kilowatt heat pump, which lifts the recovered heat up to the temperature needed for the network. There's also a 60 cubic metre thermal storage tank, which helps smooth out any short-term swings in heat demand. The network is expected to supply around 4.7 gigawatt hours of heat each year, with a peak load of around 2.3 megawatts. Importantly, the mine water resource is bigger than today's demand, so there's room to expand the network if more end users want to come on board. Over the model time, it's predicted there's going to be carbon savings of around 28,000 tonnes of CO2. This gives you a sense of long-term environmental benefits for a large-scale mine water heat use. Next, I'll show you a small video clip of the energy centre being built on site. It took around 2 weeks to complete using a modular off-site approach. This approach cut construction time considerably and reduced the embodied carbon. Very impressive stuff. Even more impressive that it was 2 weeks of sunshine in the northeast of England. And finally then, the potential. Mine water heat is a nationally significant resource and is still largely untapped. Many of our mine water treatment schemes are close to population centres and places with high heat demand. Treatment schemes are often the lowest risk and most immediately accessible opportunities because the mine water is already being pumped to the surface. It's estimated around 38,000 terajoules of thermal energy is stored in flooded abandoned coal mines. Although we can't practically recover all of this, even a small proportion could still make a meaningful contribution to low carbon heat supply. To support early engagement, MRA makes data publicly available through its online mapping tools. These data sets include mine water temperatures, flow rates and scheme locations. So local authorities, developers and consultants can do initial feasibility checks with confidence. By combining proven case studies with accessible data and supportive partnerships, mine water heat can move from a niche innovation into mainstream infrastructure. This can support decarbonisation, regeneration and long-term energy resilience. Thank you.